Hi everybody, last little topic for linear algebra. We would have learned in year 8, maybe in year 9, that two lines are parallel if their gradients are the same. Similarly, two lines are perpendicular at right angles to each other if their gradients when multiplied together equal -1. So what does that look like? Oops, that's not very good. I can do better. X-axis, y-axis, some line. So there's a line. If a line was parallel to it, that's not parallel, that's converging. Oh, that's slightly better. Okay. Again, that's converging. Converging just means that they're going to meet at some point. We don't want them to meet, but it's very hard to draw on a stylus. That's a little bit better. Okay, these lines are parallel. Their gradients would be the same. Now, two lines that are perpendicular, that angle there will be a right angle. Now, their gradients have a specific property that if we multiply them together, the answer will be -1. So let's have a look quickly at what that might look like. If we had y equals 2x plus 1, the perpendicular, any perpendicular to that would have a gradient of -1/2. So for instance, in this case here, that might be y equals -1/2 plus 20. And this gradient times that gradient, 2 times -1, will equal -1. And that's all this part up here says. So if we wanted to find the perpendicular of the first equation, or a perpendicular of the first equation, we might go y2 equals -1 over m1. So that's not y2, that's m2. Equals 1 over m1, which might be m2 equals 1 over 2. Oops, don't forget the negative. And that's where it comes from. Now there's an exception to this. If we have a horizontal and vertical line, we know that that's x equals a, or x equals c and y equals d. This doesn't hold true. You just have to remember that horizontal and vertical lines are perpendicular. Once you've understood that, go ahead and complete exercise 4D. There's lots of examples of perpendicular lines on there and they're worth looking at. Thank you. Nice short one today.